Okay, so acid and base spills. So there are many uses for both acids and bases in our household and industry. So due to their reactivity and corrosiveness, special care must be used when they are being produced and transported. So there are two ways to deal with acid or base spills, and these are 1. Dilution, which is to reduce the concentration by adding water, or 2. Neutralization. And you can always use a weak acid or base for the neutralization so that you aren't left with another hazardous situation. Acids and bases and pH. So ion concentration in water. The self-ionization of water is very small, only about 2 in 1 billion. We'll go from a molecule of water, into some hydronium and hydroxide. So the concentration of hydronium ions and hydroxide ions are equal and constant in pure water, so around 1.0 times 10 to the negative 7 moles per liter. Now, the pH scale. So in 1909, Sorensen devised the pH scale. It is used because the hydronium concentration is very small. So at 25 degrees Celsius, standard conditions, most solutions have a pH that falls between 0 and 14.0. It is possible to have a negative pH and a pH above 14. It is a logarithmic scale based on whole numbers that are powers of 10. There is a 10-fold change in the concentration of hydroxide ions for every change in 1 on the pH scale. So, a solution with a pH of 11 is 10 times 10 or 100 times more basic than a solution with a pH of 9. So, the pH scale ranges from 0 to 14, with from 7 to 14 being more basic, and from 7 to 0 being more acidic. And 7, of course, is neutral. So to calculate pH and pOH, we use the following equation. pH is the negative log of the concentration of hydronium ions. So here's our new significant digits rule. When you report pH or pOH values, only the numbers to the right of the decimal place count as significant. So when we look at these, a concentration, if we notice here, the red digits are those which are significant. So when our concentration has two significant figures, our pH has two significant figures behind the decimal place. So here's an example. 6.3 grams of HNO3 is dissolved in 750 milliliters of water. What is the new pH? Well, I know that this is the ionization equation that forms. I know my mass, molar mass, and volume. I need to figure out the number of moles. What I need to figure out is the concentration of hydronium ions. So I do this calculation to figure out that I have 0.09 repeating moles. I use my concentration because I have my volume. And I should get a concentration of 0.13 repeating moles per liter, and that is the concentration of HNO3. Well, it's a 1-to-1 ratio for hydronium ions, which means that that is the concentration of hydronium ions. So the pH now becomes the negative log of the concentration of hydronium ions, and I should get 0.875 as my pH. So, just as pH deals with hydronium ions, pOH deals with hydroxide ions, where P just means the negative log. So at standard temperature and pressure, pH plus pOH is equal to 14, So if I have my pH scale and my pOH scale, they will be in reverse, So, to calculate the pOH, use the same formula as pH, but substitute in the hydroxide concentration. So, pOH is the negative log of our hydroxide. And we use the same rules. Now, we're going to look at, if you're given one, how to calculate the other in the next video.